Hello everybody, welcome to this lecture on functions in Boolean algebra. So, a Boolean variable say x is a Boolean variable, it can take value either 0 or it can take a value 1. So, a Boolean function is nothing but an expression which is formed with binary variables. So let me just write it down. It is an expression formed with binary variables or Boolean variables. And this expression will also have the Boolean operators. That is and, or, and not. Okay, so I can write something like this. Say f is equal to x plus yz dash. So here you have, which are the Boolean variables? The Boolean variables are f, x, y and z. Which are the Boolean operators? That is and, we are using and here, we are using or, and we are also using not. So together this part is called the Boolean expression, and when we assign this Boolean expression to a Boolean variable, this whole thing is known as your Boolean function. So f is equal to x, y, z dash is a Boolean function, whereas x plus y, z dash, this is a Boolean expression, whereas f is assigned x plus y, z dash is a Boolean function. So this is a Boolean expression and this is a Boolean function. A Boolean function f can also be written as like this. F is a function of the variables x, y and z. So I can also write it like this, x plus y, z dash. So this is another way of writing a Boolean function. So the Boolean function, any Boolean function will f here, in this case the Boolean variable f will get a value based on the values of the expression that is given out here. So whatever is the value of this expression, it will be assigned to f. Okay, so we can write it in the form of a truth table. F, okay, x, y, three variables x, y, z. Then I have z dash. All right. Then I have y, z dash. Then I have x plus y, z dash. So this is our f. So with three variables, I have 8 combinations: 0, 0, 0, 0, 0, 1, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0 and 1, 1, 1. So here z dash column will fill up first. So z dash would be, here is a 0. So it will be 1, 0, 1, 0, 1, 0, 1, 0. Okay. Then yz dash would be 0, 1, this is 0, 0, 0 is 0, 1, 1 is a 1, 1, 0 is a 0, 0, 1 is a 0, okay, 0, 0 is a 0, then I have 1, 1 which is a 1 and 1, 0 which is a 0. Then we have x or y, z dash. That means this column or this column. So I get 0, 0, it's 0, 0, 0 is 0, at least one must be a 1 to get a 1. So here y, z dash is a 1, 4th row both are zeros. Fifth row, this is a 1. Then sixth row also, this is a 1, this is a 1, this is a 1. So our function f, this is the value of our function f. So for different values of x, y and z, f will get this particular values. So if the input is 1, 0, 0, my output of the function would be 1. If it is 1, 1, 0, output would be 1. But if it is 0, 0, 1, then my output would be 0. So these Boolean functions are very useful in designing our logical circuits, because basically logical circuits will take some input, and depending on what it has to do, it will produce some output. So we can represent the logic inside a digital circuit with the help of these Boolean functions. Now there is one question which says that, is a Boolean function, is it unique? Can only one expression, like say this expression here, can only this expression give me this column? Give for a given input x, y, z, 3 variables. Can I get this combination, that is 0, 0, 1, 0, 1, 1, 1, 1? Can I get this column only for this expression? The answer is no. Okay, you can get many expressions which can give you the same output given the same input. So a Boolean function is not unique. It's not always unique. So I may have multiple functions which gives me the same output. So say for example, let me write this. f1 is a function. It is written as x dash y dash z plus x dash y z plus x y dash. Okay, and I have f2 is another function which is x y dash plus x dash z. So these two functions, if you try to draw this or put it in the form of a truth table, so x, y and z, okay, you have f1 here and you write f2 out here. So 0, 0, 0, 0, 0, 1, okay. Now f1 is a combination of x dash y dash z or x dash y z or x y dash. So you can have multiple columns to find out these. So I will leave that work to you and I'll just fill up this. So I have a 0, I'll get a 0 here, I'll get a 1 here, 0, 1, 1, 1, 0 and 0. Okay. So I'm leaving this to you to work out individually each of these and then write down and construct f1. Same way I can for f2 also, I can write down x y dash one column, another one, x dash z another column, and then do the OR of both and get f2. But let me just write it down here. 0, 1, it is 0, 1, 1, 1, 0, 0. Yeah. So here you see f1 and f2, both of these are same. The output is the same. You get the same output. For the same input, you get the same output. So the functions f1 and f2 are said to be equivalent. But if you look at the expression, the Boolean expressions, these are different. So but you can see the difference between f1 and f2. The difference is that f1 has got more terms. Each of this is called a term. Okay, each of this is a term. This is a term. This is a term. These are terms. So f1 has got more terms, whereas f2 has got lesser terms. Also, let me just write f1 here again. X dash y dash z plus x dash y z plus x, y dash. Okay, so each of this is called a term. Okay, and in each term, each of this is called a literal. Each of this is called a literal. So here the function f1 has got 3 terms, and in the first term you have 3 literals, in the second term you have got 3 literals, in the third term you have got 2 literals. In the function f2 I had x, y dash plus x dash z. Okay, so here I have number of terms is 2. First term has got 2 literals, second term has got 2 literals. So you'll find that f2 is a more efficient representation of the function as compared to f1. Why? Because f1 has got more terms. More terms means more computations, and each computation is taking in more literals, so that means again even more computations. So here I have to do complement, then 2 ends. 2 ends. Here also I have to do 1 complement and 2 AND operators. Okay, and here I have to do 1 complement and 1 AND operator. And finally I have to do 2 OR operators. Here I have to do 1 complement, 1 AND. Here I have to do 1 complement, 1 AND, and only 1 OR operator. So which one is more efficient? F2 as compared to F1. That is why what we do is, we given any expression, given any function, okay, we try to simplify that function so that it has got the minimum number of terms and minimum number of literals. So in our next video we are going to discuss how to minimize or how to reduce the number of terms and literals, or in other words how we can simplify our functions.